Thank you everyone for joining us today for the innovation. My name is Monica Novick. I'm the Director of the Partnerships team here at the Commission for Excellence and Innovation in Health. And I'm pleased to be hosting today with Dr. Kimberly Humphries. Before we start, I'd just like to acknowledge that the lands we meet on today are the traditional lands of the Kaurna people and that we respect their spiritual relationship with country. We also acknowledge the Kaurna people as the custodians of the Adelaide region and that their culture and heritage beliefs are still as important to the living Kaurna people today. And I'd also like to acknowledge those people who are joining us from different lands across this wonderful country. And I'd like to acknowledge that the dreaming is still living from the past into the present and into the future forever. So just a few little housekeeping things before we commence. Your chat is turned off, but you can start the discussion on this showcase by adding a question to the Q&A tab, which is at the top of your bar. Should be around the middle. So feel free to add questions as we go so that you don't forget them. The presentation will be recorded and we will publish it on our website in a few weeks when we'll let you know once it's published. Please note that this session has been preset to keep your mics on mute and the video feed turned off by default. However, once we get to question time and once the presentations are concluded, we will cease recording and your video and mics will then be available so you can switch on your cameras and we can have an open and frank question time, which will not be recorded and will not be published. So thank you. So finally, a bit of housekeeping. After the Q&A, there will be a quick survey for you to complete, and we would appreciate you taking a few minutes to complete this to assist us with the evaluation of the event. And that helps us inform future sessions and make sure that we are tailoring and responding to the feedback, which is really important because this session is all for you guys. So for those of you unfamiliar with the Commission on Excellence and Innovation in Health, or the CEIH for short, we're a lead agency in South Australia for innovation in healthcare. And we love to bring consumers, clinicians and other collaborators together to turn ideas into better healthcare. Our vision is together creating health and prosperity for all. To do this, we're supporting the sector to come together to imagine new ideas for better healthcare. We also acknowledge that better isn't always excellent, but we're committed to measuring what we do so we can understand the impact change is having. So what if the big idea was connecting all the smaller ideas? This is the essence of why we host the Improvement and Innovation Showcase, helping to connect people, ideas, and sharing innovations and improvements, and also, some of the challenges and failures because we learn from them as well. And we're pleased to host these sessions and involve people from all across South Australia, and we've also been lucky in this showcase to have attracted people from right across Australia as well. So it's our pleasure to bring this to you. So this is a 40-minute session in a series, providing space to explore what people have learned, and we aim to keep it simple and share the work that is happening, not just waiting for work until it is complete and ready to be published. We focus on work in South Australia, but every now and then we share our showcase across our state to ignite ideas. So have you got a story to tell or share? Have you succeeded in solving a problem? Have you learned something whilst trying? Do you have themes you'd like us to explore? please do not hesitate to contact us on our email address and share with us some ideas on what we can explore in future. So it's my pleasure now to hand over and introduce Dr. Kimberly Humphries, who we are co-hosting this series with for 2024. Thank you, Kimberly.
Perfect. Thank you so much, Monica. So as per its strategic direction, the CEIH recognised the importance of addressing environmental sustainability in all facets of healthcare to reduce system impact on climate change and identify opportunities to adapt to its impact. That's why for Series 13, the CEIH and the SA Health Climate Change Executive Governance Group, which we affectionately call CCEG, have coordinated to deliver a webinar series aimed at shining a spotlight on environmental sustainability in healthcare. So this series was put together in anticipation of the launch of the SA Health Climate Change Framework, which recently underwent a period of public consultation. That consultation is now finished, and we're just compiling that feedback and revising that framework, and hopefully that will be released in the coming months as well. So quite an exciting piece of work. Throughout the series, as many of you would know because you've joined us, we've heard from a range of speakers who have shared their insights on work happening across the sector, from ways to build climate resilient health systems to innovative decarbonising initiatives. We hope that the past sessions and today's content will inspire and equip you to consider how you can be agents for positive change in your respective workplaces and jurisdictions. It is now my great pleasure to introduce Jack Noonan, who is a project manager, mechanical engineer with over 10 years of experience within the Adelaide construction industry. Jack has specialised in mechanical engineering and sustainability consulting in private industry with a focus on healthcare projects before transitioning to public sector project management. Jack has previously led the Women's and Children's Health Network Engineering Building Services and major capital projects team, overseeing asset management and project information and development throughout WCHN's 160 plus building assets, with a key focus on sustaining the existing Women's and Children's Hospital. Jack is currently the portfolio manager on the new Women's and Children's Hospital project, focusing on the design progression of the hospital, and leads the project team environmentally sustainable design, having played a key role in progressing the commitment to 100% electrification of the new Women's and Children's. So it's my great pleasure to welcome Jack to speak now. And Jack, I'll hand over to you. Thank you.
Thanks, Kimberly, for that introduction, and thanks, Monica, and Kimberly for hosting and having us talk here today. So as Kimberly has touched on, my role at the moment is with the New Women's and Children's Hospital project. We're managing the project through the end of concept design as we embark forward on schematic design, which will be a fun process. I also would like to acknowledge the land we meet on today is the traditional lands of the Kaurna people, and that we respect their spiritual relationship with their country. And we also acknowledge the Kaurna people as the custodians of the Greater Adelaide region, and that their cultural and heritage beliefs are still as important to the living Kaurna people today. So before I start talking about sustainable design for healthcare facilities, I thought it'd be good to touch on an understanding of what sustainable design in general is for this group, and specifically for healthcare facilities. So I did a bit of research and had a read around what the different clinical users of facilities and people like the Australian Medical Association, what the consideration of sustainability is from a clinician's perspective, and that really plays a role in how we design our healthcare facilities. So what we talk about with sustainability is the ability of something to continue over time. And in terms of environmental sustainability, it's what we can do specifically in the healthcare system to sustain and maintain our current environment while continuing to deliver effective healthcare services. And as Kimberly has touched on, the main focus of the CCEG is looking immediately at minimising the role of the healthcare industry on exacerbating climate change and minimising essentially our greenhouse gas footprint as a whole industry. So that is a starting point to touch on currently, what are we doing that isn't considered sustainable? And this is a graphic that I thought I'd throw up that just touches on the various different aspects of what sustainability is in a design process, and for the healthcare industry, talking about things like sustainable construction processes, sustainable operational processes with renewable energy and low greenhouse gas energy sources. Efficient building operation as well, not just from an energy perspective, but sustainability is developing over time to focus not just on the built environment and how we build and maintain and run our facilities, but also looking at the health and well-being of building occupants in the healthcare sector, and that's specifically those people that enter our hospitals, our consumers and our staff who spend a lot of time working in these environments. Like I said, today we'll more touch on the design process and the maintenance and operation of healthcare facilities, which is where my experience lies. So 3 sort of key environmentally unsustainable practices that we know of in today's environment. We can look at water consumption and how we use particularly potable water and clean water in Australia, knowing that historically we have had long periods of drought and periods where we have had low water supply and water issues moving forwards. Secondly, waste and procurement. So we know that waste processes in this country specifically are probably not where we would want them to be at this time in terms of our recycling industry and the waste management industry. And then we can look in more detail at our greenhouse gas emissions footprint. And again, this will sort of form the basis of the presentation today, is how we can look at decarbonisation of our healthcare industry and decarbonisation strategies. So I'll draw on my experience both from the Women's and Children's Health Network and for how the new Women's and Children's is progressing with our sustainability design to look at decarbonisation, not just in construction, but also in operation for what will be a new, quite significant hospital in Adelaide. So what is decarbonisation? It looks at specifically the scope of the emissions and your emissions boundary for a facility, both in construction and in operation. So this is split into 3 different areas. Scope 1 are your direct emissions. So this is emissions that are associated with day-to-day operations. And for healthcare facilities specifically, these are things like burning gas on site, which is done broadly throughout the built environment, not just in Australia, but globally. And that is to do things like heat our buildings, heat water for sanitary purposes. And it can also be used for energy generation on our sites. The Women's and Children's, as an example, has a generation facility which burns gas to provide electricity, hot water, and steam. Gas is also quite heavily used within the food services within hospitals. So that's another end use that we need to consider. There's diesel consumption for our emergency backup power and generators. And this occurs generally on a monthly basis because you have to test these generators to make sure they're going to operate when you need them. And quite a significant source that goes unnoticed, well, is becoming more prevalently noticed, I should say, are our anaesthetic gases, specifically things like sevoflurane, desflurane, and nitrous oxide. And then we also need to look at refrigerant leakage as a direct emission source on site for our air conditioning systems and refrigerators and those kinds of things. Scope 2 emissions largely relate to indirect sources. So these are emissions that are generated off-site, but that are required to power day-to-day operations at our healthcare facility. And these are largely associated with the consumption of electricity. Now, we know in South Australia, we're rapidly progressing towards a decarbonised grid and looking at the SA government's 100% net renewable energy grid by 2027. So that is one area where we can capitalise in South Australia as a rapidly decarbonising state, with the East Coasts following, and Tasmania also leading the country with their hydropower as well. Scope 3 emissions are the difficult ones. They're much harder to quantify, and there's currently a lot less data available in Australia to consider these emissions and how they impact our emissions footprints. They'll cover things like I said, with our waste generation on different facilities, which really starts at the procurement process as well. So considering how Our procurement processes and our upstream emissions from all the materials that we procure, our large BME items of equipment, our ongoing medical devices that can't be reprocessed that are single use. All of that needs to be factored into our procurement processes and our waste consumption at some point, but unfortunately, it's very difficult to quantify and capture at this point of time. Water consumption is another item we need to consider, and our business travel. And I know this graphic indicates that company vehicle emissions can be associated with scope 1. Generally, it's easier to consider them with scope 3 and group them with a holistic business travel emissions footprint assessment. So those are really a lot of the things that we need to consider from a healthcare facility moving forwards. This is an example of the Women and Children's Hospital as the key facility of the Women's and Children's Health Network. This is an example of the available data that we have at this point in time to begin considering what a healthcare facility's emissions footprint might look like, which is really the starting point to inform what your decarbonisation options are and how you can then implement strategies to reduce your emissions footprint. So this is data that's largely available from utility billing data. You've obviously got your bills that come in from your natural gas providers and your electricity providers. Again, consumption of diesel on site, refrigerants that are needed to recharge air conditioning systems and fridges and freezers, as well as your anaesthetic consumption. So we take this directly from our medical gas providers, just on the billing data that we have available, and the water consumption. Sorry, shouldn't have skipped forward there. So this is a very high level example with data that we have available that can estimate what an active healthcare facility's emissions footprint is like now. Now, I must note that this is work that myself and Rob Bunting within the SA Health team as SA Health Sustainability Lead have undertaken on our own. This is by no means a comprehensive emissions assessment, which needs to be undertaken by professionals really as the first step in understanding how we can decarbonise our industry. But based on our experience, this is an example that we feel relatively confident in being able to share as a current understanding of realistically our scope 1 and scope 2 emissions at a healthcare facility. As I've said, scope 3 information is not widely available and quite difficult to be able to quantify, often requiring some estimated emissions factors. I'll note that waste isn't included in this. From my understanding from my time at the Women's and Children's, where I tried to find the data on waste associated emissions, is that our waste contractors in Australia are not required currently to undertake greenhouse gas emissions assessments or reporting. And that's even under things like the National Greenhouse, the NGES scheme, the Greenhouse Emissions Registration Scheme. So that's a bit of a hole currently in our assessment that we just can't estimate. What this data shows us is that in our current facilities, our largest source of emissions is going to come from natural gas. And that's a pretty straightforward thing to consider. Our electricity, as we've touched on, is rapidly decarbonising with our grid, and gas forms a very large portion of operating facility emissions. Nitrous oxide is quite another significant emitter. The Women's and Children's Health Network are currently pretty actively reducing their sevoflurane and desflurane usage, and they're moving towards, particularly for operating anaesthetics, they're moving towards total intravenous anaesthetics, TIVA, as an alternative to using sevoflurane and desflurane. In a facility like the Women's and Children's, where nitrous oxide is such a well-known, relatively safe analgesic, and it's quite heavily used in birthing procedures and in a paediatric environment, it's going to be very difficult for us to reduce the consumption of nitrous oxide. So through discussions with clinicians, that's something we've identified as we're not going to be able to do, reduce the consumption of it. Fortunately, there are schemes that I can touch on a bit later, which can look at the reduction of emissions associated with nitrous oxide. And yeah, we can touch on those as we go through. I will flag for this facility, while I was there, we were moving towards reducing our gas consumption. So this is an average annual emissions from the 2018-19 period to 23-24. Over that time, we have tried to move away from gas as much as possible. Like I said, that site had gas generators for power, hot water, and steam. We were looking at eliminating what we call a cogeneration facility there to reduce our gas consumption and replace that, unfortunately, with gas-powered boilers, which is not the most environmentally beneficial option. However, we have to consider the remaining life of that site, noting the New Women's and Children's is programmed to be opened in 2030. So we're talking about a facility that has 6 to 7 years left. So our alternative for hot water and heating a site is air source heat pumps, which have quite a significant engineering impact and other considerations to build on, which can't be accommodated at a facility that only has realistically 6 to 7 years left of operation. However, moving 2 boilers away from cogen will significantly reduce that natural gas consumption. It will increase the electricity consumption, but with electricity continuing to reduce its emissions footprint, by 2027, that should be a net zero emission source, and the gas emissions associated should reduce significantly. At the bottom here, I've indicated what an average annual car equivalent of these emissions are, and that data has just been taken from the Australian Bureau of Statistics based on average car distances travelled in a year and average emissions intensity of a passenger vehicle. So you can see that the Women's and Children's, based on the emissions that we can currently calculate, equates to about 6,500 cars on the road a year. So it's just an example for us to consider as we look at our decarbonisation moving forwards. Like I said, waste, unfortunately, waste contractors don't currently calculate or report on their greenhouse gas emissions associated with their waste collection and waste processing. So it's not available for us to consider in our footprint. We can consider our waste streams and where they go. Obviously, elimination of landfill is a key priority for, I would think, the majority of sustainable thinking organisations and healthcare facilities. Difficult to do for a healthcare facility, but there are alternatives that we can consider. South Australia currently, we have what is termed an alternative waste treatment scheme, the AWT, which can take all of our dry waste and remove it from landfill. So I must note that it is dry waste. It's not, nothing wet can go into that scheme. What happens with that alternative waste is it is taken away from what would be going to landfill and it's brought to Adelaide Brighton Cement, who use it in furnaces as part of their operations. So it essentially burns that waste. While that is not necessarily the most sustainable practice for that waste, it's better than landfill. So it's a starting point for us to consider as we look at other alternative options to increase recyclability. And that's one thing I will say, that alternative waste treatment scheme, while better than landfill, may not necessarily be better than recycling that waste and reusing it. However, in lieu of the data to inform that decision, we'd be just guessing at how much more beneficial recycling compared to an alternative waste treatment scheme might be. So that's something I'd really advocate for, is that our waste industry in general really need to start collating this data, calculating it for us and providing feedback to their clients on what the waste emissions associated with each individual stream are. It's not an easy task. As you can see there's quite a few different streams of waste that are collected from healthcare facilities, from putrescible, electronic, secure documents, the alternative waste stream that I've touched on, grease traps, steels and metals, cardboards, polystyrenes, commingled recyclable waste, and secure product destruction and liquids. So there's quite a range of different streams that would need to be considered in that. But I think it's just necessary for us to be able to have the data to make an informed decision moving forward on what the best way to handle our waste is from an environmental perspective. And that might not be from just a pure emissions basis, but the emissions source of our waste is certainly something that we need to consider in making that decision. So decarbonisation options in healthcare. Particularly around operations. So I've touched on some of these already. So the SA grid like I said, in South Australia, we're very fortunate to be in a position where we're approaching 100% net renewables and should expect to be there by 2027. So electrification of our healthcare facilities needs to be a key priority to decarbonise the healthcare industry. Consuming gas is far too emissions intensive in comparison to an electrification option. Now, in an operational facility, there are considerations you need to do that. Considerations you need to take into account, particularly around central energy plants. And these are the big pieces of equipment that heat and cool our hospitals. This is specifically looking at heating. So the alternative for gas-fired boilers or cogeneration is air-sourced electric-powered heat pumps. When you think about them like your air conditioning systems at home that have an outside unit that either, depending on whether you're cooling or heating, will reject heat or absorb heat. When we're looking at trying to heat internally within buildings, we're looking at those systems absorbing heat and redirecting it inside our buildings. The difference between the ones we have at our home and the ones that we have for hospitals is the size. They are significantly large pieces of equipment. Depending on the size of your facility and the heat load required to heat your facility, we could be talking about hundreds of square meters worth of plant that needs to be accommodated. That cannot be accommodated where boilers are usually located. Boilers are usually located inside a plant room that is ventilated, but it's just ventilated to allow the burning of gas. Whereas heat pumps need to be located with access to adequate outside air. So generally you'd like to locate them external to a hospital on a roof potentially, so that they can absorb heat from the external environment, redirect it through its refrigerant cycle to air conditioning systems inside that will distribute that heat throughout the hospital. So that is a major plant change that needs to be considered for our operating facilities, and it doesn't come at a small cost. So these things need to be done generally, tying in with the end of life replacement strategies for our boilers. Our hot water systems are the same. So currently they're gas fired to heat water. Electric powered air sourced heat pumps can do the same thing. You have the same considerations you need to take into account. They need to be located outside with adequate access to the external environment to absorb the heat to inject into our water systems to heat it. Is a large one. So as I've touched on, reducing consumption is a starting point. Appreciate that in all facilities that's not going to be possible. The next thing we need to look at is leaks in our nitrous oxide systems. So SA Health has a nitrous oxide working group that's an amalgamation of all of our local health networks at the moment who are looking at our nitrous oxide systems currently. And the general consensus of that group is that we need to start looking at an alternative to our centrally located nitrous oxide manifolds and distribution systems. Nitrous oxide is quite a volatile gas in comparison to our other medical gases. It will eat away at the rubber components in our pipework and connection points to blending valves and other kinds of valves and equipment that we plug into it, and it will leak at those places. It will also leak at the manifold. The other difficulty is it's very hard to monitor and leak trace, find where it's leaking and resolve those issues. So you end up with systems that leak nitrous oxide directly to the environment. Nitrous oxide has an emissions footprint of approximately 300. So every kilogram of nitrous oxide leaked is the equivalent of 300 kilograms of carbon dioxide. So it's quite a significant emitter in our healthcare systems. So like I said, the consensus of that group, of the nitrous oxide working group, is looking at moving away from central manifolds and central systems in favor of portable bottled systems. If one of those is identified as leaking, you take it out of commission and repair it and replace it. You've got a much smaller leak risk from that system. And the benefit is that you can have multiple types of those systems throughout a facility that can potentially be shared, but appreciating that there are pretty dedicated uses for nitrous oxide in our healthcare facilities, particularly when we look at ones like the women's and children's, where they'll be located in the birthing departments and pediatric emergency department, your pediatric inpatient units where they're used as an analgesic as well. So yeah, that we'd be looking at potentially portable systems to replace central ones. The other part of this is looking at scavenging and destruction of gas. So the destruction of nitrous oxide is a pretty simple catalytic conversion process. So think about the catalytic converter you'll have in your car that reduces the emissions that come out of your tailpipe. It's the same process. You look at passing nitrous oxide over a hot plate that breaks it down into harmless nitrogen gas and oxygen gas that just goes back into the environment as compared to nitrous oxide. The difficulty is the efficiency of destruction is directly correlated to the efficiency of scavenging. So you need to make sure that whatever you're administering to a patient is also scavenged. Sorry, whatever you're administering to a consumer is also scavenged. So that leads us away from the typical breathing tubes that we use in Australia that can be breathed in through the mouth. You're potentially breathing out through your nose. You might remove the breathing tube as you exhale. So there's a lack of scavengeability there, and replacement with masks that are generally cover your nose and mouth. They'll administer nitrous oxide, they'll scavenge it, and you can take it, pipe it directly through bidirectional breathing tubes back to a destruction unit and destroy the nitrous oxide. There are portable destruction units out there on the market that are available. They're relatively new. They're of course relatively expensive. So it's quite a cost-intensive option to consider. But if we're serious about wanting to reduce our emissions associated with nitrous oxide, it's something that we need to consider. Water is another one that we need to look at considering. So not just from a decarbonisation option, but like I said, in Australia, where we're quite susceptible to droughts, we need to look at reducing potable water consumption as much as we can. There are opportunities for this. You've obviously got rainwater capture and storage, which I would hope a lot of facilities do. There is also the Glenelg to Adelaide recycled water scheme. SA Water take all of our wastewater, recycle as much as they can, push it back out to facilities where it can be used for non-potable water sources, things like landscaping or your toilet flushing, and for engineering processes like into your cooling towers and other things like that where water is consumed. SA Water are also working towards a net zero energy consumption option from energy consumption operations. So they're looking at being energy independent from our grid, which is also tied in with renewable energy, and they're looking at being zero emissions as well. I believe that's a project they're working on and targeting for 2030. Refrigerant is the next thing we need to look at. So our air conditioning systems and refrigerators use refrigerants that have a global warming potential, an emissions intensity of anywhere between 100 and 15,000. There's quite a range of refrigerants out there that can be very emissions intense. There are low global warming potential GWP refrigerants out there on the market that are starting to become more prevalent in our large pieces of equipment in our central energy plants that replace our existing refrigerants, which are quite emissions intense. So as we replace refrigerant in these systems as it leaks or is lost through maintenance and other things, we can replace them with lower GWP options. And as I've touched on, waste really needs to be considered. Until we get that information from our waste management contractors, we need to start thinking about our procurement streams and waste reduction in terms of quantity and mass, because that's the first step. Obviously, if we produce less waste, we will also produce less emissions associated with waste, and less will go to landfill. But we need to really make decisions on separation and recycling of waste happening at our points of care as a starting point, and then looking at what recycling streams we employ that will have the lowest impact on the environment and the lowest emissions footprint when we get that data. Construction emissions are the next thing that we consider in a project like the New Women's and Children's. There's upfront carbon and there's embodied carbon. So upfront carbon is really the emissions that are associated with the production, transport, and construction of our projects. So that's generally handled by a managing contractor or a builder who will procure and build our facilities for us. We'll set targets for them to achieve, and through the design process, we'll identify how that is done. The builder obviously brings some procurement strategies and some smarts into that process and assists us where they can, and they're essentially responsible for trying to minimize our upfront carbon as much as possible. What we also need to consider during design is the embodied carbon. So this is the emissions associated with the use, maintenance, repair, replacement, it's the ongoing life of our facilities and how they evolve over time. You know, when floor vinyl wears out and we need to replace it, or we need to replace ceilings or walls, or make modifications to our building and sustainment programs throughout our healthcare facilities, we really need to consider the emissions associated with the construction processes at that time and the materials that we're replacing our facilities with. There's also the end of life carbon associated with the demolition of our facilities and those sustainment programs that occur in our facilities. So ensuring that the waste from those demolition activities is taken and disposed of in an adequate way. What is excluded from this whole of life carbon process is the benefits that might be taken out into the next process. So how much of our material might be taken and recycled and reduce emissions associated with the upfront carbon of the next project. We don't count that during the demolition process. That's a benefit for the next project to take out of it. And then down the bottom here, you can see where our operational carbon comes in, and that's the scope 1 and 2 emissions and 3 emissions that I've touched on earlier. So this was an assessment undertaken in the very early stages of the New Women's and Children's Project, where we looked at what the 50-year life cycle emissions of our facility might be based on traditional construction methods and traditional operation. So you can see that the operational energy dwarfs everything else. So this is if we continue to use gas as a heat source for our facilities. Operational gases is still significant in here. So this is our nitrous oxide, and you can see the construction emissions process is actually quite a small, it's a relatively small portion of the pie compared to our operational energy. This would all be expended during the construction process and a little bit throughout the management of the facility. But largely our operational energy dwarfs everything else. So this is the largest source that we need to look at. Like I said, in South Australia, we are very fortunate that our grid is going to be 100% renewable by 2027. When this assessment was undertaken, we were looking at a 100% renewable grid by 2030. So this is a little bit skewed compared to where we are now. But you can see, based on the design decisions that we made at the time, and that was namely electrification of our project, moving away from gas as an energy source in the New Women's and Children's Hospital, you can see the operational energy is significantly reduced from an emissions perspective, quite significantly. And the material embodied emissions with the incorporated in the construction and maintenance process of the New Women's and Kids is by far the largest portion of our emission of the pie, our largest emission source. Operational anesthetic gases come in at a second there. So this is where nitrous oxide becomes a much more significant emission source, and we really need to consider moving forwards how we deal with nitrous oxide as an emitter. The others in there, the material end of life, our replacement and refurbishment. So this is the sustainment programs that occur at our healthcare facilities in maintenance and upgrades over time are considered. Operational waste. Now, this is an estimate. There are emissions factors out there that have been based on processes that occur on the East Coast. However, it is a white paper that gives us these emissions factors. It's not widely used industry standards and calculation methods that our waste contractors need to develop and employ on our behalf. So we've made an estimate here of what our operational waste emissions would look like. So touching on our construction emissions, which as we saw in the New Women's and Children's world will be the largest source of our emissions over 50 years, we need to consider what our emissions reduction associated with construction is going to be. This is this was undertaken quite a while ago on our project. We've started our planning for sustainability right from master plan through concept. You can see that the structure of the building is by far the largest emitter in the construction project process. So this is things like concrete for our piling, floor slabs, beams and columns, as well as the steel that reinforces all of that concrete. Those two things are the majority of our construction associated emissions. We step through then looking at building services, so our electrical switchboards, cabling, our air conditioning systems, the pipe work used for various different systems throughout a hospital with our fire protection, our med gas, and water distribution throughout sites. These are all things that we need to consider how to reduce the emissions associated with them as we build the new Women's and Children's Hospital. There are design frameworks out there, things like Green Star, who provide targets for you to try and reach in terms of your emissions reduction strategies associated with construction. We're looking at a 10 to 20% target to reduce our construction emissions by. So we will build a baseline of emissions based on traditional construction methods, and we will then look at our emissions reduction strategies, and we'll try and improve on that baseline by 10 to 20%. And Green Star as the verification team, sorry, the GBCA is the verification team for the Green Star buildings tool. Will independently review that and provide verification that, yes, we are improving over a baseline construction emissions boundary. So to do that, we need to look at things like low emissions concrete. Construction emissions are quite a difficult thing to mitigate. It's becoming more prevalent in the construction industry to target low emissions materials. However, on the scale of the new Women's and Children's Hospital at $3.2 billion, there is going to be a lot of concrete and a lot of steel used on this project. On a project of this scale, it's going to be difficult to achieve those targets. That's not to say we're not going to do them. They're targets for a reason, and we're anticipating getting to them. But going through our procurement processes and seeing how that's going to be done, they're quite costly items that need to be undertaken. The strategy to get there is still in development. But on the scale of this, on this scale and this size, it's quite a difficult process to undertake. And that needs to be taken right through the design process and in conjunction with contractors who begin to come on board as that design progresses and we move towards a construction process. Realistically, in existing facilities, if we were to look at reducing construction emissions, reuse of structure is the best way to do that. Now, our healthcare facilities, which are termed as critical infrastructure, and they're critical infrastructure for a reason. These are places that house our intensive care units and emergency departments. It's where people go in the event of an emergency, and they need to continue to stand in any emergency that occurs. So as Australian standards and the National Construction Code and things like this progress over time, generally the structural requirements become more stringent. So reuse of structure isn't something that necessarily can be done. And similarly, low emission structural materials, things like timber, are difficult to implement because they don't have the same ability to withstand fire or seismic provisions. So in an earthquake, in comparison to concrete, we need to be sure that they're going to operate to the same level of structural stability. And without any historical evidence of that, it's quite difficult to be the first person to build a hospital or something out of timber when you're not 100% sure and don't have the previous experience of knowing how it's going to operate. But there are certainly alternatives out there to concrete and steel which can be considered in the healthcare industry for less critical infrastructure and for other building projects out there on the market. So this is just touching on the emission reduction strategies again before I get into the next slide, which combines all of this data into a holistic life cycle view of where we could be compared to where we want to go. So again, electrification, reducing our construction emissions, nitrous oxide reduction, both consumption and scavenging and destruction, water reduction, and low GWP refrigerants. These are all things that we're trying to implement on the new Women's and Children's Hospital project to reduce our our construction emissions and our operational emissions. So this is that overview. The pie chart on the left and the data on the left-hand side of this screen show the 50-year emissions associated with traditional construction methods and traditional operation methods. So you can still see there that natural gas is included. Electricity is based on our historical emissions and historical grid emissions intensity. Diesel consumption, I'll touch on because that's a bit of a special case. It doesn't really change. Refrigerants, the left is using standard refrigerants. Nitrous oxide is business as usual. Central manifolds and pipework and not scavenging in destruction, and an estimate of what our construction emissions may be for the New Women's and Children's Hospital to give you a total annual emissions intensity and an equivalent passenger vehicle. Sorry, it shouldn't be annual. It should be a total 50-year emissions intensity and the vehicle equivalent for over that 50-year period. The right-hand side is the new world where we can reduce these emissions through things that are occurring now. So electrification, you immediately see natural gas is removed from our hospitals and there are zero emissions associated with it. Our electricity grid is moving to its net zero, 100% renewable grid and will be zero emissions. So you can immediately eliminate emissions associated with electricity consumption on site as well. So your scope 1 and scope 2 emissions decrease massively in the short term. Diesel consumption won't change. We will still rely on diesel for emergency power requirements. Our healthcare facilities, and particularly something like the New Women's and Children's, has quite a significant electrical consumption, electrical load, and there are no viable alternatives currently to move away from diesel power generation in emergency scenarios. And we, like I said, we need to be prepared for any emergency that may occur. A grid failure is one of those that in South Australia we have experienced as recently as 2017. So we need emergency power provisions for that eventuality. Moving away from standard refrigerants in favour of low GWP refrigerants can reduce the emissions associated with our refrigerants there. Nitrous oxide, moving away from our central manifolds and more portable systems and incorporating scavenge and destruction. This is one that's difficult to estimate, again, because it is so reliant on the efficiency of scavenging to then get your destruction. So this is just an early estimate of what that might be able to do, and it's a 50% reduction based on the consumption not changing between our existing facility and our new, which is a big assumption, but it's a starting point. SA water post 2030, moving again into a net zero operations. So no emissions associated with our SA water, potable water supply, recycled water supply, and waste discharge from site for processing. And then construction emissions being reduced by up to 20%, which is a target. So you can see over that 50-year period, it is a significant reduction in emissions, moving from traditional construction and operations methods to the future. And yeah, so this is touching on how we implement those. I think I've already spoken a lot about this. Electrification is really the key thing that our healthcare facilities need to target. It is going to be the #1 thing that reduces your emissions pretty significantly and very quickly. And it can be paired with low GWP refrigerant replacements as well to get you a bit of a 2-for-1 hit. Anesthetic gases are the next one that we really need to consider. This needs to be led by clinicians. Clinicians are the ones who use anesthetic. They know its importance, and they know how at times difficult it can be to utilize, and scavenging again is not a simple process. But if you do pair portable delivery systems with effective scavenge and destruction, there's potentially quite a significant operational emissions reduction that can be implemented reasonably quickly as well. Noting that our scavenge and destruction systems are available on the market now. And then construction and facility management practices. So funding is a key thing for decarbonisation. This isn't going to happen without an injection of capital, not just across our new hospitals that we are building, but our existing facilities, the ones that do currently use things like gas. They need to be funded to move away from gas consumption and into electrification. These aren't cheap processes. It will cost millions of dollars per facility to incorporate these things. It's something that government really needs to consider if we're serious about decarbonisation of our healthcare industry. And the next steps, like I said, our construction practices of air and our nitrous oxide are really the immediate steps that we need to take. But then we need to get serious about our scope 3 emissions as well. There's a process associated with decarbonisation of our organisations and our industry. It really starts with rigorous accounting processes, which needs to be undertaken by professionals. They need to be provided with all the data that we have available, from our utility billing to how we're using our network vehicles, to how people are getting, consumers and staff, how people are getting to our sites. And our emissions boundaries need to be set based on those scope 1, 2, 3 emissions, and a serious accounting process needs to be undertaken. We need to consider the procurement chain. So there is an international standard out there that discusses sustainable procurement processes. This includes, at a starting point, asking our suppliers of equipment for their sustainability information. What's their emissions footprint for the production of materials and the equipment they're supplying us with? What's the emissions associated with the transport and delivery of these materials to site? They need to start giving us this information so that we can start considering it in our procurement processes and incorporating ranked, weighted criteria into our procurement processes as well. Our waste management, as I've touched on, we as clients, we need to demand sustainable reporting from our suppliers, and that includes the emissions intensity of the individual waste streams that we are utilising to develop those statistics and understand then and inform our decision making moving forwards. It's all about evidence-based design and evidence-based operations so that we can make informed decisions. And accurate financial reporting and emissions accounting associated with our investments and financial expenditure on things like business travel and vehicular movements. And then again, the final two that I'd like to touch on aren't decarbonisation related, but again, Australia is susceptible to droughts, particularly South Australia. We know this. We need to be looking at our water consumption and how we minimise potable water consumption. And that is things like rainwater, recycled water, and using grey water or recycled water and rainwater for non-potable sources where we can. That's me done. Thank you, everyone.